This short video is to introduce solving linear equations where there's no power of x, so there's no x squared in there, there's no square root of x, just linear powers of x. And the key is that you can do what you like to the equation so long as you do it to both sides of the equation. So you can multiply, add, subtract, divide, square, all these different functions you can do. The trick is knowing the best thing to do in any given situation, and the only way to get to that point is to practice. So let's have a look at some examples taken from the text. The first one, solve the equation 4x equals 20. Well, it's probably obvious to you that x is 5 because 4 times 5 is 20. But let's just think about the process that we're going through to solve this. 4x equals 20. If you look at the left-hand side, the x has been times by 4. So the idea is to try and undo what has been done to the x multiplied by 4 to get back to the x. So if I want to undo multiplied by 4, I divide by 4. So I'm going to divide both sides by 4. Note both sides are divided by 4. So 4x divided by 4 equals 20 divided by 4. I'm dividing both sides by 4. This undoes the effect of multiplying, so actually it cancels out those. So really I could just write x equals 20 divided by 4, which is 5. Solve. So you can go straight from here to here, but the process is undoing what you did. Looking at this one, if we look at this, solve 2x divided by 5 equals 6. Looking again at the left-hand side, then what's happened here is I've multiplied by 2 and I've divided by 5. So I've done two things to x. I've multiplied by 2 and divided by 5. So I undo those. It doesn't matter which order I do multiplication and division, so I can either undo the multiply by 2 by dividing by 2, and then undo divide by 5 by multiplying by 5, or the other way around. So I'm going to multiply both sides by 2, by 5 first of all. I'd always tend to get rid of the divisions first. So multiply both sides by 5, that leaves just 2x on the left, because the 5's cancel. And what's 5 sixes? 30. Now I'm going to divide both sides by 2 to get rid of the 2. So that leaves me x divided by 2 undoes the multiply by 2, leaving just x. Dividing back right hand side by 2, x equals 15. It's a good idea to check, of course, when you do these things, to check. Put your answer back in to the original equation. 2 times 15 over 5, does that equal 6? Yes. So I know I've done it right. Here, what's happened to A? If you look at the left hand side, A has had 5 subtracted. So to undo, take away 5, or minus 5, add 5. So add 5 to both sides. So add 5, minus 5 plus 5, that's gone, so that leaves just A. I've undone the minus 5. Add 5 to the right hand side, 8 plus 5 is 13. And again we could check by putting that answer back in and make sure it works. Here, two things have happened. I've multiplied by 4 and I've subtracted 8. Now the order becomes a bit more important. If you remember BIDMAS, the order in which we do things, we start on the left and work to the right, brackets, powers or indices, division and multiplication, addition, subtraction. To solve equations, you sort of work back the other way. So if things are added and subtracted, which has happened in this case, you do that first, get rid of those first, then you do the division and multiplications, and then brackets, powers, that sort of idea. So in this, I'm going to add 8 to both sides first. So add 8. That gets rid of the minus 8, leaving just 4x on the left hand side. 12 plus 8 is 20. And then divide both sides by 4. And you get x equals 5. And again, I could put this answer back in and check it worked. Here, we have a situation where x appears on both sides, look. And in these situations, the first thing to do is try and get x's together. So let's have a look at this. 6x plus 1 equals 2x plus 9. If I subtract 2x from this right-hand side, I get rid of the 2x on the right-hand side. But I must also subtract 2x from this side as well. So what I do is I try and get rid of the smaller amounts of x to make sure I leave a positive number of x's if possible. So I'm going to subtract 2x from both sides, which means I'm left with just 4x plus 1 on the left-hand side equals 9. Now I have a situation very like the one that I had before. I've just got x is on one side only, and so now get rid of the 1 by subtracting and divide by 4. See if you can carry this one on and get the answer and check for yourself that it's worked. Here's another one. If we look at this one, 4 minus 3p equals 2p minus 11. Again, if you look at the left-hand side, minus 3p on this side and on the right 2p. So I've got p's on both sides. But now, if I add 3p to both sides, I'll get rid of this one, leaving a positive 2p, positive p's on the right-hand side. So add 2p is the best way to go. So I end up with 4 equals 5p minus 11. Now add 11 to both sides to get rid of the minus 11 on the right hand side, and carry on and see if you can complete that and check. In situations like this, I have a bracket to multiply out, and I can go two ways. I can either multiply out the brackets, or I can get rid of the 3. So let's try both and see which one we think works best. Remember, it doesn't matter what you do, so long as you do the same thing to both sides. So first of all, I'm going to divide by 3, both sides by 3, which means x minus 2 equals 3. There's no need to put the bracket in now. And then add 2 to both sides, x equals 5. Taking the same problem, I could multiply out the brackets. 3 times x is 3x. 3 times minus 2 is minus 6. Now I'd add 6 to both sides. And then I'd divide both sides by 3. Same answer, but I think you'd agree that there's a few more steps and it's a bit more awkward on the right hand side. So it's choosing the method. They both work, but sometimes it's about choosing the most appropriate method. In this last example, I would multiply out the brackets this time and then collect together all the like terms. So let's see how we go. Multiplying out the brackets. 4 times 2r is 8r. 4 times minus 3 is minus 12. Minus 2 times r is minus 2r. Minus 2 times minus 4, be careful of this one, minus 2 times minus 4 gives positive 8. Equals 3 times r is 3r, 3 times minus 3 is minus 9, minus 1. Now collect together like terms on the left and right hand side. 8r minus 2r is 6r, minus 12 plus 8 is minus 4. So I get 6r minus 4 equals 3r minus 9 minus 1 is minus 10. Now I'm in a similar position to where I was in the previous two examples. So see if you can carry on and finish this one off. Put R back in and see if it works. And then when you've done that, have a go at the exercise that follows in the text.